This lesson will be on graphing straight lines. What I'll do is I'll work through one question, but I'll work through it in quite a lot of detail so that hopefully you can pick up all the different concepts that are involved in graphing straight lines. So let's have a look at the question. Find the gradient x-intercept y-intercept and sketch 2x plus 3y equals 3. So what we've got here is a linear equation, 2x plus 3y equals 3. So what we've got here is a linear relation. Now there's a couple of terms in this question that you might be unfamiliar with. First, the gradient. The gradient of a line is the slope of the line. The x-intercept is where it hits the x-axis, so where the line hits the x-axis. The y-intercept is where the line hits the y-axis. Now, in order to find the gradient, what we want to do is to just write this linear relation in what we call the gradient intercept form. Now, the gradient intercept form is y equals mx plus c, where this m value is the gradient, this c value is the y-intercept. So let's rearrange this linear relation into gradient intercept form. So we want to make y the subject, so 3y equals 3 minus 2x. So all I've done is bring the 2x over to the other side. Now we want to divide everything by 3 because we want y by itself. So we'll get y equals. The other thing I'll do is I'll write the minus 2x first, just because that's how we've got it in the gradient intercept form. So minus 2x over 3 plus, so this is this 3 here, 3 over 3 is 1. So I'm just going to write 1. So now we've got it in gradient intercept form. And from this, straight away, we can identify our y-intercept of 1 and our gradient of minus 2 over 3. So y-intercept equals 1, gradient equals minus 2 over 3. And this is enough information to sketch this graph. So let's draw up a Cartesian plane. So we've got our y-axis, our x-axis, and we know that the y-intercept is 1. So let's make a little marking here of 1. And the gradient, as I said before, is the slope of the graph. And the slope of the graph is the rise of the graph over the run of the graph. The rise being the vertical, the run being the horizontal. So the gradient equals rise over run. So our rise is -2, so we're actually going down 2, and our run is 3. So we can start at our point 0, 1, move down 2, which would take us to -1, and then our run is 3, so we're going across 3. So we'll go 1, 2, 3, and we'll make a little point there. So we know that this line goes through the y-intercept of 1, and the gradient being -2/3 means that it goes through this point as well. If we ever want to sketch a graph, all we need is to know 2 points on the graph, and now we've got those 2 points, so we can go ahead and sketch it. So let's sketch a line that goes through those 2 points. So it will look something that's probably as close as we can get it there. So we know this point here is 3, -1, and we know this point here is 0, 1. Now, I've also asked you to find the x-intercept. In order to find the x-intercept, we need to solve the linear relation for when y equals 0. The reason why we do that is because when the line goes through the x-axis, the value of y is 0. In the same way, if we were to find the y-intercept, we could let x equal 0. We already know the y-intercept is 1 because we've got it in gradient intercept form, but if we were to solve it for x equals 0, we'd get y equals 0 plus 1. So we know that the y-intercept is 1. If we want to find the x-intercept, we'll solve for x equals 0. And we can either solve it with the relation in its original form, so 2x plus 3y equals 3, or we can solve it when we've got it in the gradient intercept form here. So to find the x-intercept, solve for y equals 0. We've got y equals -2/3x plus 1. So we'll let y equals 0. 0 equals -2/3x plus 1. Let's bring that x over to the other side. So we've got 2/3x equals 1. Let's multiply both sides by 3. 2x equals 3. Now divide both sides by 2. X equals 3/2. And that's our x-intercept. So if we come back up here, we know that this point here is 3/2, or 1.5. And that's all the information that we've been asked to show on this graph. We've got the y-intercept and the x-intercept, and we put it in the gradient intercept form, so we showed the gradient there as well. Now there's a couple of things that are important to know. So we've finished with that question, but there's just a couple of extra things that are worth noting. So there's different types of gradients that lines can have. They can have positive gradient, negative gradient, they can have a zero gradient, and they can have an infinite gradient. So what I'm going to do is I'll draw up a Cartesian plane and just go through the different types of gradients. So a line with a positive gradient will always be running this way. So this is positive. A line with a negative gradient, as we saw in that previous question, will always be running this way. So that's negative. A line with a zero gradient, and maybe you can think about this intuitively, if a line's got a gradient of 0, it doesn't have any slope at all. So that just means that it's a flat line, it's a horizontal line. So a line with 0 gradient will look like that. And a line with an infinite gradient, you might be able to deduce, is a vertical line. So it doesn't have a rise over run. There's no run, it's only a rise. So a vertical line has an infinite gradient. So those are the different types of gradients that you can have. Hopefully that's been a helpful overview for you in graphing straight lines.